Since this is a course where we're going to try to use science to answer technical questions about the world around us, I thought I would begin with an Excel demonstration using the recent football controversy that some call DeflateGate. So this is an example of how you can calculate the final ball pressure using the standard general chemistry ideal gas law, and we're going to do a bunch of unit conversions in this example. So we're going to begin with the inputs, as we've heard about in the press, and that was the gauge pressure for the football was 12.5 psi. So you notice I've labeled the inputs, gauge pressure, psi, and it's gauge pressure because this is the pressure inside the ball. And it's reported that the ball temperature was around 75 degrees Fahrenheit. Those units are inconvenient, so we're going to convert to atmospheres. And this is atmospheres total pressure inside the ball. So that's going to be D5, and notice I've got a blue box around the D5, plus 14.7 because there's 14.7 psi of external atmosphere pressing in on the ball. And then I've divided by 14.75 to give me the total pressure inside the ball in units of atmospheres. And this unit comes from 14.75 psi per atmosphere. Okay, so there's almost 2 atmospheres of pressure inside the ball. The ball temperature in degrees Celsius is D6, notice the box, minus 32 times 100 over 180. So that's the standard equation from converting from Fahrenheit to the centigrade scale. We need to use the Kelvin scale for the ideal gas law, so we've added 273.15 onto the ball temperature in degrees C. Okay, now we're going to come over and look at the ideal gas law. And we know from general chemistry that P1 V1 equals NR T1, or if we have a different set of conditions, P2 V2 equals NR T2. And we're going to assume in this case that the ball doesn't lose any gas. So moles, N is constant, R is a gas constant, so NR are constant. So using those constants, I can rewrite these expressions in terms of NR and say that P1 V1 over T1 equals NR and P2 V2 over T2 also equals NR. So notice NR is a constant. And because it's a ball, V is a constant. So the gas law simplifies to P1 over T1 equals P2 over T2. All right, so here we go. P1 over T is 0.006229. Notice all I did is take D9 divided by D11. And our conservation equation says that the final P over T has got to be the same, so I've set them equal. And now we come down to the outputs. The final ball temperature was reported to be about 45 degrees. So 45 degrees Fahrenheit is D18 minus 32 times 100 divided by 180, 7.22 in the centigrade scale or the Celsius scale. The ball temperature is 280.4 on the Kelvin scale. And we can now calculate using our P over T conversion. So P over T times T will cancel the temperatures and give me just pressure. So D15 times D20, and the final pressure will be 1.75. That's in atmospheres, so we need to convert it back to gauge pressure. D22 times 14.7 gets me into PSI, minus the 14.7 external pressure, and the final ball pressure is 11. So, if the referees measured a ball pressure of around 11, it is entirely reasonable to conclude that the ball's deflated due to a change in temperature. Oh, and in case you missed it, the Patriots did win the Super Bowl.